Hello, and welcome back to the Microservice Architecture and Design Pattern series. Today, we are going to have a look at the Saga Orchestration Pattern. In a microservice architecture, business operations rarely complete in a single service. Placing an order is not one action, it is a sequence of coordinated steps. And once data is distributed, traditional database transactions no longer work. This is where the Saga pattern becomes essential. Let's take a simple but realistic example. We have an order service and we have a payment service. A client calls the order service using place order endpoint. The order service creates the order and publishes an order placed event. At this point, the system is in partial state. The order exists, but the payment has not yet been confirmed. Now, the question is critical. What happens if the payment fails? In a monolith, this would be handled with a database transaction. Either everything succeeds or everything rolls back. But in microservices, each service owns its own data. There's no shared transaction boundary. We cannot lock multiple databases and we should not try. We need a different consistency model. The Saga pattern addresses this problem. A Saga breaks a long business transaction into multiple local transactions. Each step updates its own data and publishes an event. If something fails, previous steps are compensated. This is not rollback, this is explicit compensation. There are different ways to implement sagas. Choreography, orchestration, for example. In this video, we will focus on saga orchestration. In orchestration, a central service controls the flow. It knows the sequence and it decides what happens next. This avoids hidden coupling and unclear event chains. Here is how it works in our example. Step 1. The client calls place order. The order service creates an order, publishes an order placed event. Step 2. The orchestration service consumes this event, it executes the business workflow, it calls the payment service using the pay endpoint. If payment succeeds, the saga continues. The order moves forward. If payment fails, the saga must compensate. The orchestration service calls the order service's cancel endpoint. The order is moved to a cancelled state. Sustained consistency is restored, no distributed locks, and no partial failures. I have a blank solution created in Visual Studio called Saga Orchestration. Let's add an ASP.NET Web API project to it and call it Orchestrator Service. We don't need HTTPS for now. Let's create the solution. Let's add a record type to represent a saga. Let's call it as order saga request. We'll add a couple of properties such as order ID and a new GUID to individually identify the saga request. We'll add a corresponding constructor. Now, typically, sagas are long running processes. So, the consuming business microservices cannot wait for the saga to complete or fail. So, individual microservices will publish an event, and that event will be written to a channel, and the orchestrator service will refer to that channel to get the messages and perform the execution of the overall business saga. Now let's add a class to represent the channels. Let's call it as channel provider. We'll add a private read-only channel to it. This channel will be of type order saga request. We'll add a channel reader and channel writer, and let's add a constructor to initialize those readers and writers as well as the channel. Let's move those types to their respective files for clarity. Let's add an endpoint called publish to this orchestrator service. Let's inject the channel provider. We'll accept the event name from the route itself. If the event name is order placed, then we'll read the request body and create a new order saga request. We'll write the saga request to the channel and return the OK response. Let's add a class to represent the complete order saga. Now, this could be a workflow, this could be external service which represents the overall business process. For demo purpose, we'll create a class and let's call it as order saga. Let's inject few properties such as HTTP client for the payment service and HTTP client for the order service in it. We'll hardcode the base addresses for now, but you can use the service discovery pattern which I have explained in my other videos to locate the payment and order services. Let's implement and execute a sync method which will accept the order saga request. First, we'll try to perform the pay action by calling the payment HTTP client get async method. We'll ensure that we get a success response. We'll simulate a long running business process by introducing a delay. Now, this could be a multi step business process. Once everything is successful, then we'll call the complete endpoint of the order service to ensure that the order is fully completed. If the payment service fails or if there is any other exception, we'll simply call the cancel endpoint of the order microservice. Let's move the type to its own file. As I mentioned earlier, sagas are typically long running business processes. So let's implement an order saga using background services. Let's call it as Saga service. We'll inject a service scope factory and the channel provider into this service. Let's implement the execute async method of the background service class. Now, this Saga service will read for messages in the channel. We'll create new scope and instantiate a new order Saga object. And we can call the execute async method of the Saga. Now, this starts the Saga execution. Let's move the type to its own file. Now, publishing an event to the orchestrator is kind of a repeated task. Let's put it in a common place called as class library. Let's add a class library project to this solution. Let's call it as orchestrator service lib. Let's add an interface called iOrchestrator client to this class library project. Let's add a method called publish to this interface. We'll use Newtonsoft JSON libraries JObject class for simplicity. Let's rename this file to iOrchestrator client. Let's implement this iOrchestrator client interface on a class. Let's call it as orchestrator client. We'll inject HTTP client and iConfiguration service in this class to read from the app settings file. Let's read the configuration where orchestration service is located. Let's create an HTTP client and set its base address. Let's implement the publish method of the iOrchestrator client interface. We'll read the data object, convert it to a JSON string, and call the publish endpoint of the orchestrator service. We'll ensure that the response is a success. Let's implement a couple of business microservices using ASP.NET Web API. Let's call it as order service. Let's implement another business microservice called as payment service. Now in both the business microservices, let's add a reference to the shared library project. Now in the order service, Let's register the HTTP client as well as the orchestrator client. Similarly, in the payment service, let's add the required services. In the order service, let's add an endpoint to allow end users to place an order for a certain amount. Let's log the amount and ID to the console, and then we'll publish the order placed event using the orchestrator client. Similarly, let's add an endpoint called as complete, which will be called by the orchestrator service once the payment is completed. Let's add an endpoint called as cancel, which will be called by the orchestrator service once the payment fails. Let's switch to the payment service. In the payment service, let's add an endpoint called as pay, which will take order ID from route in the input. We'll put some dummy business logic here. So if the order ID contains the word failed, then we'll simply return a bad request. Otherwise, we'll return an accepted request. Now back in the orchestrator service, we need to register a few services to use the background service as well as the channel provider. Let's add those services. We need to register the order Saga object. The channel provider needs to be registered as a singleton, and the Saga service will be registered as a hosted service. Let's install the required NuGet packages and bring in the using namespaces so that we get rid of the compilation errors. Let's jump to the demos. I've opened the orchestrator service, the order service, and payment service in command prompt. Let's run the services using .NET. Let's run the order service as well using .NET run command. Now the orchestrator service is listening on this port, order service is running on this port, and payment service is running on this port. Now let's place an order for a good customer for amount 200. We get 202 accepted requests. Now let's move back to the terminal window and see what was the overall saga. Now on the terminal, I can see we get an HTTP request for order placed, good customer 200. We also published an event called order placed. On the orchestrator, we received an event for order placed and the saga for order creation started. We attempted the payment, and then payment was for a good customer. The payment was completed, and we called the complete endpoint on the order service. Now let's test the negative scenario where the payment fails. Let's send a request to the failed customer for similar amount and see what happens. Back in the terminal window, we placed an order, and when we published an event, it went to the orchestrator service, we got event received, and then we attempted to pay. Now, since it's for the failed customer, the payment failed, and we then called the order cancel endpoint. And the cancel endpoint for failed customer was called, and we received 202 requests. This is how we can implement Saga orchestration using ASP.NET Web APIs. Saga orchestration gives a structured way to handle long-running business transactions in microservices. Instead of distributed database transactions, we use explicit coordination and compensation. In our order and payment example, the orchestrator drives the workflow and restores consistency when failure occurs. This makes the system more predictable, observable, and easier to evolve as business logic grows. This concludes another example of microservices design pattern. Please do watch other videos in this series and give thumbs up if you liked the video. Please subscribe to my channel to get more YouTube videos regarding microservices and architecture. Thank you for watching.